Hello everybody, I'm Nick, and in this video I'm going to talk to you about logging in dotnet and why you probably are doing it wrong. Now this video has to do with performance, and like anything performance related, you have to put everything you see here in the context of your use case. It doesn't mean that just because I'm talking numbers and allocations and everything, you have to go with the most extreme solution right out of the get-go. You have to be pragmatic with your choice and choose which one you want to go with, but you will also know how to optimize when you need to. So that's what this is about. You don't have to worry about prematurely optimizing your code, but you will know how you can, because logging actually, if done wrong, and most likely it is done wrong, can really cost you some performance. If you like this type of content and you want to see more, make sure you subscribe, earning the same notification bell, and for more content, check out nickchapsas.com. And talking about nickchapsas.com, I just bundled up both my courses for a discounted price as part of my Essentials bundle. So I highly recommend you check that out in the link in the description. So what do I have here? Well, let's start with this basic web API because I want to explain the problem here. So I have this controller here, this weather forecast controller, and I've only changed it a little bit. I'm accepting a days parameter over here, which by default is 5. And then I am logging in a debug log that I'm retrieving the weather for an amount of days. The days is a parameter over here. And then I'm using that to retrieve the weather. And if I was to run that, let's see how that looks like from an API perspective. So I would call that with a days of 3, and I'm getting 3 days back. Pretty straightforward. Now, as you can see down here, I am logging that in debug mode. However, debug mode by default isn't enabled in ASP.NET Core. Actually, the default is information. You can change that in the app settings file. And if you see here in this app settings.development.json file, this is where I'm changing it. I'm changing the default log level to debug. These log levels mean that you will only log in a given medium. In this case, it's the console, but it can be the file system. It can be Elasticsearch. It can be tons of things. But it means that anything below that threshold will not be actually logged, and anything above it will. So if this was, for example, information, which is a level higher, then the debug log would not actually appear in the console. And we're going to see that in a second. Let me just revert that back. So we have that debug here. And this app settings.development.json is driven by the ASP.NET Core environment variable. And you can see that in the launch settings. In here, I have this logging best practices.api.dev, which is what I just run up here. And as you can see, I'm using the development ASP.NET Core environment, and that's how this is loaded. Anything that doesn't have a specific environment suffixed app settings file will default to this app settings.json. So in our case, this production one will actually use this app settings.json, and in this one, because it's production and we don't want to overlog because overlogging actually is bad, we apped the default log level to information instead. And in that case, if I go ahead and I run that over here, you will see that when I call that endpoint now, we're not actually logging anything in here because that is a debug log and it's totally being ignored. However, and this is where the trap actually lies, we still actually call that method. And this is bad because the log debug or any log extension method on the iLogger, which is the default one, is using the parameters object array. Why is this bad? Well, an object array means that value types need to be boxed to be put in that array. Plus it's an array, meaning that this will be allocated on the heap. Let me show that actually in action. If I go back to actually, let's keep that to prod and do a debug here. Since this is prod, this debug log will not actually be output anywhere, will be completely ignored. However, when I call this endpoint, this method will be called. And that's bad because if I go over here and I load memory and then I step over it, obviously there is nothing in my console because the debug log is lower than information, so it's ignored. But if I go back to memory and I reload, you can still have obviously the string allocation of the log, but we also have one new object array over here, And we also have an int32 down here. And the int32, you can bet money that it is the 3 that we just allocated, which is one of these two. And the array, and I'm not going to search all the one item arrays over here, but one of these arrays contain a 3. I'm not going to open every single one of them, but you can trust me, that 3 is there. And that's bad because even though the console logger behind the scenes will check whether that's enabled and not actually log in the console, you still waste memory on allocating both the array and also boxing the value, even though it's not used. So the simple solution to this is that you can say if logger dot is enabled, and then you provide a log level. So you say log level dot debug. So if that's enabled, then you log it. Now, this looks a bit clunky, doesn't it? Because that means that every time you have a log message, you have technically to have this over here. But as you can see now, if I rerun this and I go back to the memory diagnoser and I call that endpoint and we've hit that breakpoint, if I load memory again, we have that. But then I step over that call and we didn't even touch this line. And then when I load again, none of anything in here was allocated. Any allocations were done in that call necessary to make sure that this isn't called. So you can see here that no int32 was actually allocated. Now, because this is a bit abstract, I want to put that into perspective and run some benchmarks to see what it really means in terms of performance. So I have a benchmarks project here. Let me just close everything but that. And I have pre-allocated a constant string here and a log message. This one has parameters, this one doesn't. And I'm using the iLogger factory, which behind the scenes is used to create a logger. And I'm creating a logger here. It's a read-only one, reused for every test. So let's say that we have a benchmark here, which is a public void log without if. So this is your default logging approach. So it is logger dot information. And because this is warning, the actual output of this method will be ignored. So we don't really care about how this performs when you're actually logging something, because that logging needs to happen. That's fine. But when you don't need to log something, because the log level is higher, but you're still calling that method, what's the impact on that? So here I'm just going to have first the log message that doesn't have any parameters. And then I'm going to have the alternative that has an if. So with if. So if logger is enabled, and obviously this will be false because, well, this is warning, so it will be ignored. But let's run a benchmark with these two and change that to release and select the right one. And if I run that benchmark, let's see what's the difference between something that calls the method, but obviously the output isn't used, and something that calls the method only when the log level is enabled. So results are back, and let's see what we have here. So the with if takes 3 nanoseconds and the without if takes 14 nanoseconds. Now, what I forgot to do is slap a memory diagnoser here, and this will let us know how much memory is actually allocated in these two use cases. So let's go ahead and rerun this and see what the memory looks like. Now, we don't have any parameters here that need to be allocated, so I would expect the memory to be 0 for both. But this will become a bit more interesting when we add the parameters into perspective. So let's wait for this to finish and then talk about how that affects performance. So results are back, and let's see what we have. So like I said, no memory allocated for neither of those. That's because we don't actually allocate anything. The string here is pre-allocated in this const, so we're fine. However, what happens when I duplicate that and I bring log without if with params, so with parameters? So this is the log message with parameters, and I can have a couple of, or a few actually. How many do I have here? 1, 2. Let's delete one of those. Why not? So let's have a couple of random things over here. Here we go. And then let's duplicate that over here. And then I'm gonna slap that name here. And now with the parameters, which will be formatted into the log message, let's see how allocations mostly is affected. So let's give that a go and see how it goes. So results are back, and as you can see, the first values are the same, but the second one, we have 88 bytes allocated here, which is these value types being boxed in the array. But the one with the if doesn't have any of that memory problem because the code doesn't even step in here. Now, I would expect this and this to perform the same because effectively they are the same thing. But to my surprise as well, this one took longer. Now, that being said, when I was preparing for this video, it was way closer. So I don't know what happened there. Maybe a fluke with an underperforming core running the tests. I don't know. But the main point is the memory, because that's really what's going to really affect your performance, because more memory you allocate, the more garbage collection you have to do. And when something's being garbage collected, your application is just paused doing nothing. And it's dead time, which the users will actually experience. Now, you might be looking at this and be like, okay, 88 bytes, big deal. But let's actually take a look at what this really means in the context of your application running. So what I have here is a console application that will just log a random number, which is probably the first time I'm using an actual random number, but it's going to log a random number with information as the log level. So you can see it here. And if I change this to warning, the minimum level, then it's going to execute again and print nothing because the log level is again higher than what we're actually logging. And I'm going to use this use case to run a memory profiler. Now, for this to actually print something meaningful, we have to run this for quite a long time or quite a few iterations. So we're going to move that over here and I'm going to change this to that. Here we go. And now if I run that, let's see for how long it would run in the console. So this is running, still running, still running. I can hear my CPU still running, and that's finished. So it runs for, let's say, 5 to 10 seconds, which is more than enough. Now, do you see this color being shown here, which is quite different than anything you've seen before in my ID? Well, if I hover over that, you can see that it detected 2 issues, and it tells me that this allocated what is 3 gigabytes or 3.6 gigabytes of memory during that execution, even though nothing was printed. Now let's take a look at this in more detail, right? And for that, we're going to use dotMemory, which is another JetBrains tool I'm using to profile the memory of my applications. It doesn't have a dark theme and it doesn't have a font increase functionality. So you're going to be blinded in 3, 2, 1 now. Sorry for that. Now, what I can do with this is I can execute my application through this and see the memory and see how the memory is allocated, managed, unmanaged, heap generations, garbage collection, all that good stuff. So I'm going to try to zoom in here and I'm going to go ahead and show you how to use it. So I'm going to press the add button here. Then I'm going to find my .NET Core application in the path and I'm going to go to the bin release .NET 6 location. And I'm going to select the exe. So I'm going to double click that. I'm going to say save. And if I zoom back, you can see this now loaded. And over here, I'm going to use full. The process filter is the default and the control of the profiling is manual. And then I'm going to just press the start button and watch what happens here. You see this going up and then down and up and down and up and down over here. These orange things down here, these orange small dots. Let me just stop this. This. These are garbage collections. It's points in time where .NET is just clearing the memory and it effectively pauses the application to clean up the memory because pressure is being built. And if I stop showing unmanaged memory, you can see how it's going higher, pressure is happening, and then it's garbage collecting. And if I actually collect a few snapshots, so I have this snapshot here, then let's have another one. And then in a second, let's have another one. So I can now kill this process. And as you can see, during this execution, let's say this block over here, we allocated, let me just zoom in up here, 1.4 gigabytes of memory. So this was only halfway through its execution. And in 52 seconds of execution, the GC time was 2 seconds. This is a low bloody GC time because that's time the app is doing nothing. Imagine in a single minute, if you're building a game, like a game server, that the server pauses and does nothing for that time. Imagine if it's an FPS, how bad of an experience this will have. And this obviously scales with anything you're doing on a high throughput scenario. So we're not talking small numbers here. Yes, I'm doing many iterations, but we didn't even get through half of those in this execution. And if I click on the snapshot, I can drill into what is being allocated, but I know what it's being allocated. It is this, so I don't need to drill into anything really. Now, if I was to change that and had the if logger is enabled thing, and I said log information, and I put that over here, and now I rebuilt it. Here we go. Went back to dotMemory and I started it again. Watch what happens now. That's it. It's finished. It went through 69 million and it's done. I didn't cut. It just did it because none of that memory was ever allocated. It iterated over that. It maybe allocated something here initially to bootstrap the application, and that's it. It's done. So you can see what difference this thing can actually make. Now, something else, which is a bit of a bonus point, is that if you are using string interpolation here, so you're doing something like that, that's also very, very bad. Watch why this is very bad. I'm going to go ahead and comment out this. In fact, this is worse than doing the boxing and array allocation thing, because in here, you're allocating a new string every single time, while in reality, this should be treated as a template, not as the message, and any parameters should be added as, you know, the way I showed before, the way where you have a parameter and then the value in the parameters array. Let's see if I build this, how the memory performs now here. So I'm gonna go back on this one and rerun it. And as you can see, we have way more garbage collection now. Let's get a snapshot here. The memory is loading up way faster because strings are more expensive. And you can see, let's just let it run for a little bit. Let's get another snapshot. The reason why the memory drops after the snapshot is because it is triggering a garbage collection. So don't be fooled by that. I mean, we're running it for quite a long time, so I think I can now just kill the process. And if I select all that, this is 2.3 gigabytes of memory in a shorter period of time. Remember before, let me just zoom in, before it was 60 seconds and we had 2 seconds of garbage collection, but only 1 point something when it comes down to memory. This is way, way more memory because strings are so much more expensive. So if you are using string interpolation in your logging, bad, don't. You really want to use the parameter-based approach, because in that way you only allocate the string template once and then the parameters are being added by the framework behind the scenes. So that's a better way to do it. Now, how do you fix it without just using is enabled everywhere? Because there is a compromise here. Well, what you can do, and I'm going to go in the benchmarks project and add it here, is create a logger adapter. And this is really relevant if you're not using Serilog. I will explain why. But if you're using the built-in Microsoft logger, you really should take a look at this. So iLogger adapter here, and an adapter effectively will wrap our logger calls. That's for two reasons. First, it's very hard to mock the iLogger interface because it's calling into internal classes, so it's a bit clunky. But it also allows us to do the following. Normally, by default, you have this log information call here, which is just a string, which is the message, which is really the message template. And let's go ahead and add the iLogger adapter here. And I can change that to use the same generic t-type parameter if we want to. So let's do that. And then you can have the same log information thing, but instead of using a parameters array, we're going to use generics. So we're going to say arg0, and I'm going to put that here. So t0, then t0, then t1 arg1, and put that here. And then same for this one, T1, T2. And usually you're going to have up to 3 arguments, most common scenarios. 3 uncommon, you're going to have more, but you definitely can. It's not like impossible, but I'm only going to keep it to 3 generic parameters in this scenario for now. So you have something like that, and then you're going to implement those members. And then what you want to do is you want to have a private iLogger of T, which is your actual logger behind the scenes, and inject that from the constructor. And the way you want to implement those methods is as follows. You want to say if logger.is enabled, and then obviously because you know that this is log information, you're going to change that to log information. Then you can now say logger.log information message. So that's what you have. And now you can copy that to every other call. So do that, and do that. And then this is arg0 here. This is arg0 and then arg1. And this is arg0, arg1, and arg2. Why is this a game changer in that context? Well, first, let me just duplicate that and create one with parameters and change that to log adapter here. So I'm going to go up here and say private read-only iLogger adapter for benchmarky. I'm going to say log adapter, and I'm going to initialize it using the logger we just initialized. I'm going to say new log adapter, logger. Here we go. Now, when I go down here and I can delete actually this is enabled thing, I can simply say logger adapter dot log information and then have my same call. And now, because these values aren't actually boxed and allocated in an array, they're just passed as generics, they won't get boxed and allocated on the heap in an array. Let's see how that looks like. I'm going to go ahead and run these benchmarks again, and let's wait for the results and see what we have. So results are back, and let's see what we have here. So here's what I was talking about before. Remember how this and this had a big discrepancy between the performance, but now they're the same? I think previously the execution of this benchmark was picked up by a weak core on my CPU, which is fine. You can see that they perform exactly the same, but you can see the difference of the with parameters and without the if. This name of this benchmark is wrong actually. This doesn't have the if, but is 9 nanoseconds, so a bit more than double the with if approaches, but there is no memory allocation because these are passed down as generics, so they stay as value types. And because I have the if check over here, they're never actually allocated until they need to be allocated in an array, which is the valid use case. So this solution is probably the best middle ground solution you're gonna go with, because memory will hurt you way more than this being 4 or 9 nanoseconds. If you ever need to optimize further for speed, then know that if you have the is enabled call higher, so outside this method, it will be better because you don't even have to deal with the method call. But for most people, this solution will fix the problem. And in fact, it is exactly what Serilog, a very popular logging solution for .NET, is doing. If you go to any of their methods, they actually use the same generic approach, and they have T0, T1, T0, T1, T2, and for anything higher than that, they have a parameters object array. And if I go into their implementations for any of these, that's what they do. They have the is enabled check to avoid the allocation because they know that this is expensive, and then they allocate all values here. And again, if you need, you can go with 4 parameters, but most likely they've done the research and they know that most log messages will log up to 3 arguments. So that's how you can fix it, and that's also the solution I would recommend to most people. Just to give you an idea, if I go to the Serilog project and I add the same looping mechanism, but without the is enabled thing, so just trust basically their code base to do its thing, and I build it and I go back to dotMemory, sorry for being blind again, and I add that application. So here we go. And before I forget, I change this to warning, so to ignore it basically. And I rebuild that. And here is Serilog. If I go ahead and run this, then as you can see, execution completed, same graph as before because the thing is completely ignored. That's why Serilog might come out as more efficient by default compared to the default Microsoft one, because it has that check that makes it not allocate this unnecessary memory. Sorry for the longer video, but I do think it's important to understand those things because logging is such a fundamental thing in our code bases, and it's so easy to also misuse it, which is maybe a topic for another video, that can really harm your application's performance. Well, that's all I had for you for this video. Thank you very much for watching. Special thanks to my Patreons for making these videos possible. If you want to support me as well, you're going to find the link in the description down below. Leave a like if you like this video, subscribe for more content like this and ring the bell as well. And I'll see you in the next video. Keep coding.